Hello, and welcome to a video presentation on points, lines, and planes. Here's what you'll learn: how to identify and describe geometric figures. What is a point? A point is an exact location in space. Points are the basic building blocks of geometry. A point is represented by a dot. To distinguish one point from another, we label or name it with a letter. In reality, points are so small they can't be shown at all. They have no dimensions. What is a line? A line is a straight path that extends forever in opposite directions. Lines are made up of an infinite number of points. However, we only need two of these points to define any line. The line above can be called line JR or line RJ. A shorthand way of identifying a line is to put a line above the letters. We could call this line JR with the line symbol above it, or we can swap the letters and put RJ with the line symbol above it. What is a line segment? A line segment is any part of a line with a definite beginning and end. In the line above, there are three different line segments. There's a segment from J to C, which is the same segment as C to J. A shorthand way of identifying a line segment is to put a line above the letters without arrows on the ends, like this. We could call it line segment JC with the line segment symbol above it, or we can swap the letters and call it CJ with the line segment symbol above it. The arrows are removed since line segments have a specific beginning and end point, and they do not go on forever past those points. Now there's another line segment from C to L, which is the same as L to C. So we can write that as CL with the line segment symbol above it, or we can swap the letters and write LC with the line segment symbol above that. Can you find the last line segment on the line above? It's line segment JL, which can also be identified as LJ. So we can write it down as JL with the line segment symbol, or LJ with the line segment symbol. Now please note, even though we've written each of the line segments in two different ways, there are only three unique line segments shown, not six. What is a ray? A ray is part of a line. It has a beginning point, but no end point. It goes on forever in one direction only. We identify rays with 2 points. The first point is our starting point, and the second point identifies the direction in which the ray goes on forever. There are 4 different rays in the line above. Let's identify them. One ray starts at point J, and it goes on forever to the right through points C and L. Since we only need 2 points to identify a ray, its beginning point and one of the points in the direction that goes on forever, we can identify this ray in 2 different ways. We can call it ray JC by writing the J then the C with a ray symbol above it, or we could call it JL with the J then the L and the ray symbol above it. Notice the notation above the letters. The single arrow notation indicates rays have a definite beginning point but no end point, and we always write the letter of the beginning point first, so the arrow will always be pointing to the right. Now a second ray starts at point C, and it goes on forever to the right through point L. So that ray can only be written as CL with the ray symbol above it. A third ray starts at point C and goes on forever to the left through point J. That ray can only be written as CJ with the ray symbol above it. For ray CJ, notice the arrow in our notation still points to the right, even though our ray goes off to the left on the line above. The fourth and final ray starts at point L and goes on forever to the left through points C and J. That ray can be written one of two ways. We can write down LC first with a ray symbol above it, or we could write LJ with the ray symbol above it. What is a plane? A plane is any flat surface that goes on without end in every direction. While planes go on forever in every direction, we show them on paper with edges, even though they really have none. A plane also has no thickness. And like all geometric figures, planes are made up of points. Like points, lines, line segments, and rays, planes have names. While it takes 2 points to name lines, line segments, and rays, it takes 3 points to identify a plane. In the figure above, we could name this plane plane ABD. Or we could name this plane DAC. In fact, we could use any combination of 3 letters that are not in a straight line. Here's why our 3 points can't be in a straight line. Consider the figure at right. There's a straight line, line R, that runs through the intersection of the 4 colored planes shown. If the 3 points in our plane happen to reside on that line, line R, we couldn't tell whether we're trying to identify the green plane, the blue plane, the purple plane, or the yellow plane. That's why our points can't be on a straight line. Now there's one other way to identify a plane. If a plane happens to have a single italicized letter in one of its corners, like ours does, we can use this letter to name the plane. So in our figure above, we could also name this plane plane F. Now let's look at some examples. Take a look at this figure and name 3 points. Now you can list any 3 of the 5 given points, A, B, C, D, and E. So let's just pick 3. Let's call points B, C, and E our answer. Let's name 2 lines in the figure. Well, there are only 2 lines in the figure. One is line AE, or line EA. The second line must use any 2 of the 3 letters C, E, and D. So let's call this second line, line CD. So now we have line AE and line CD in this figure. Now let's name the plane. You can use any 3 of the 5 letters given to name the plane, except C, E, and D. Remember, since C, E, and D form a straight line, this combination of letters would be unacceptable for naming the plane. So let's go ahead and call this plane ACD. Now in this example, let's name 3 rays. There are multiple rays in this figure, but we only need to identify 3. We can start at W and go on forever through Y or Z. So let's go ahead and call this ray WY. Now we need 2 more. We can start at Y and go on forever through X. So let's identify that ray as YX. And we can start at Y and go on forever through W. So our third ray will be YW. Now let's talk a bit about congruence. We know that figures that are the same size and shape are called congruent. The same thing can be said for line segments that are the same length. Consider the triangle at right. Notice that 2 sides of this triangle are the same length, both 10 meters. That makes them congruent. And we use tick marks on figures to indicate congruence like this. That way, even if we don't have numbers to indicate a measurement, we can still identify sides that are the same length. Now consider the rectangle above. Our rectangle has two pairs of congruent sides, but they're of different lengths. One pair of sides is 1 inch long. The other pair of sides is 5 inches long. We can still use tick marks to identify sides that are congruent, but when the lengths are different, we use a different number of tick marks to indicate each congruent pair. Let's use single tick marks for the 1 inch sides, like this, and let's use double tick marks for the 5 inch sides, like this. Now let's look at an example of congruence. Identify line segments that are congruent in this figure. Single tick marks indicate line segments DH and EG are congruent. So let's write that down. DH is congruent with EG. Double tick marks indicate line segments EF and GF are congruent. So let's write that down. Line segment EF is congruent with line segment GF. Finally, triple tick marks indicate line segments DE and HG are congruent. So let's write that down. Line segment DE is congruent with HG. We've now identified all of the congruent lines in this figure. Congratulations! You've learned how to identify and describe geometric figures.